now there is the book for boy section 2, I say, because this is involve the shift of equilibrium position. Okay, so for the question 25, okay, here you are given the chemical equation and a small amount of B is added at time T. So what is the variation of C? Okay, now we only add boy, not C, right? So that means the amount of C won't change suddenly. So A and D won't be the answer. Okay. The second is, okay, there is something wrong for the question, so for the answer D, because before adding and after adding at the same level, it doesn't make sense, right? Either it should be increased or decreased, so D won't be the answer for sure. Okay, the second part is you add boy according to the Markovnikov rule or reaction quotient, whatever you like, okay? More B will lower the reaction quotient. So we need more product to consume the extra boy. Okay? So C should be increased. So the answer is C. Okay? Question 29. So you are given the Kc for the decomposition of N2O4. Now, here is a little bit tricky, okay? This is a small trick for you, okay? The trick is, some of you may wonder which one is product and which one is the reactant, okay? So, let's see the unit, okay? The unit is mole per dm cube. That means the denominator should be the NO2 because the equation is here. Okay, only NO2 be the product will give you the unit mole per dm cube. Okay, so this is a little trick, okay, for you. Okay, so you are given the volume. So now the N2O4 is this and NO2 is this amount. So you need to calculate the reaction quotient. Okay, so let's see here. With the calculation, NO2, N2O4, the reaction quotient is 0.09. So either A or B. But if you compare the reaction quotient and the Kc, you find that actually the QC is less than Kc. That means we want more product. Okay, we want more product. So as a result, the forward reaction should be higher reaction rate than the backward reaction. Okay, here. So the answer is boy. Okay, before the end of these questions, okay, have a look. The rate of reaction. Yes, we want more product. But it doesn't mean the backward reaction is stopped, okay? It's violate the law of equilibrium. So make sure you get the clear concept. Only the forward way is higher than the backward way. Okay? Don't misunderstand that the backward way is 0, okay? Now, next one. So, you are given this and, okay, the heat change is endothermic. Okay, endothermic. So, how can we increase the number of mole of Y? That means increase the amount of product, or you may say more forward reaction. Okay, you can interpret like this. Okay, so how can we get more product? How about remove Z? Good, because remove Z will lower the reaction quotient. In order to compensate, the reaction or the system need to produce more product. It fit our idea. Okay. 2. Increase the volume of the container. Okay, now here is the second trick here. We have no idea the volume is. So what should we do is, first, you can study. In this equation, both left hand side and right hand side got the same number of mole of liquid. Okay, so change the volume shouldn't have any significant change on the equilibrium position. But if you are not happy, let's study the mathematical interpretation. Kc should be interpreted like this. Okay, mole over volume. Because you can see the volume actually can be cancelled out. Okay, so no matter how you change the volume, it won't change the equilibrium position. Okay, so increase the volume, no. Finally, increase the temperature, yes, because the forward reaction is endothermic. Okay, just like an aircon. If you increase the temperature, yes, you want aircon, right? So more forward reaction will undergo. So the answer is 1 and 3, that is C. Well, next one, can turn the color of system parallel. Okay, this is not, maybe some of you not familiar, okay? Because bromine solution is brown, but its aqueous solution is colorless. So turn the solution parallel means more forward reaction. Okay, so what should we do? First, pass HCl. Well, no, because here shows the hydrogen ion is in the product. So if you put more HCl gas, okay, that means you will increase the hydrogen ion amount. Well, sorry, no. Okay, you only get is make the equilibrium position turn to left. Okay, this is not we want. How about more HBr? No, because both H plus and Br minus will increase. In this case, again, it cannot get more forward reaction. How about adding NaBr? No, again, because this will increase the amount of bromide ion. Okay, bromide ion is the product, so we don't want more product. Okay, otherwise, okay, if we get more product, the forward reaction, okay, will be less. Finally, how about adding NaOH? Well, good, because neutralization, adding NaOH will neutralize and lower the concentration of hydrogen ion. Then the reaction will need to do something to compensate and get more forward reaction, right? So the answer is D. Okay, D. Well, next one is question 31. Okay, when the volume of system decrease, the temperature remain unchanged. Okay, temperature unchanged, very good. That means one is not correct. Okay, because Kc only affected by the temperature only. Okay, so next one is, how about the equilibrium position will shift to right? Okay, actually, if 1 is not correct, then 2 is correct for sure, because volume decrease will shift the equilibrium position with less gas molecule. Okay, so shift to the right, good. How about the rate of decomposition? Okay, now this is actually not related to the equilibrium chapter, it related to the reaction rate chapter. Okay, with less volume, that means the concentration for all species increase. So in the chapter about the reaction rate, higher concentration will increase all reaction rate for all, okay, both forward and backward reaction will increase. So 3 is correct, so the answer is D. Okay, question 26 is a bit difficult, okay, so please pay attention. Here we got a light brown gas equilibrium with dark brown gas. So the idea is the syringe is compressed. Oops. rapidly, okay, highlight, okay, rapidly. So what will be the observations? Okay, now I don't care about what will be the equilibrium shift first, okay? If you compare rapidly, that means at the first moment, the volume will decrease, or you can say the concentration for all species will increase. So the color intensity will darker. First, okay, well, because the equilibrium position or the equilibrium still not established, but at the first sight, the situation become darker, okay, then because less volume, will prefer less gas molecule. That means N2O4 will be better, okay? So the answer will be D, because N2O4 is paler, okay? Okay, this is the final question. Okay, so I think this question is a bit tricky because the keyword rapidly, okay? And from the public exam results, okay, this is not performs good in the 2012, okay? Okay, this is 29. So again, this is one of the very difficult questions, so please pay attention, okay? Here shows the forward reaction is endothermic, okay? So what will be the rate for forward and backward reaction if the system with lower temperature? Now, please forget everything about the equilibrium first, okay? In the section of reaction rate, if you get lower temperature, so what you get is both reaction rate for forward and backward will decrease. So the answer should be C, okay? So maybe you are not happy with that because in the lessons you were told if the forward reaction is endothermic and with lower temperature, the system will shift equilibrium position to left. Yes, in the lessons you were told you were teach to do so, right? So what is the reason behind? So here shows in this case, okay, in this case, so we got an example, okay, maybe the forward reaction and backward reaction, okay, the forward reaction may be decreased for 80%, but for the backward reaction only decreased for 30%. Yes, both reaction rate decrease, but I haven't mentioned what is the amount they decrease, okay? If they decrease like this, so finally you can see the backward reaction is the net reaction and fulfill what we expect, the equilibrium position shift to left, okay? So actually two ideas hasn't violate from each other, okay? In this case, yes, both reaction rate decreased, but not in the same amount because the forward reaction decreased with larger amount, so the net reaction will be backward, and hence the equilibrium position will shift to left, okay? And this is why I say this question is quite difficult.